Hello everyone, welcome back to our video class here at CSEC Math Tutor. In this lesson we are talking about histograms, and our objectives are to describe a histogram, to differentiate between a histogram and a bar graph, and to draw a histogram. And so first up we want to look at what a histogram is, and the most interesting thing that I want to point out right now is that when you look at your x-axis for a histogram, you will notice that the x-axis has a scale which is different from a bar graph, which does not have a scale on the x-axis. So there's a scale on the x-axis and also a scale on the y-axis. A histogram is used to represent grouped data, and so because it represents group data, the groups may be equal, as in this particular histogram, and in some cases they may not be equal. Let's look at the differences between a histogram and a bar graph. So notice here that this is a bar graph and the bars are individual, they're by themselves. They can be drawn connected sometimes, but the important thing to notice is that there isn't a continuous scale along the x-axis here, and there will be one on the y-axis but not on the x-axis. So notice that this histogram here, it has a continuous scale along the x-axis, and this bar graph does not. Both use vertical bars, and in the case of the bar graph, the frequency is read from the height of the bar. In the case of the histogram, the frequency can be read from the height of the bar if all the bars are the same size. However, if the bars are not the same size, then the frequency is read from the width of from the area of the bar rather, and not so much the height. So histograms and bar graphs are different. Bar graphs are normally used to represent discrete data, whereas a histogram can represent both discrete and continuous data depending on what you put on the frequency distribution, the group distribution. Now let's look at how we can draw a histogram. Let's get rid of these and do it over. So first, this question, a class of 26 students recorded the distance traveled to school, and these are the distances traveled to school to the nearest kilometer. So I have already gone ahead and filled out the missing parts of the table, the missing frequencies here. And so to draw a histogram, we need two things. We need the boundaries and we need the frequency. So the boundaries are found from the limits. And let's take, for example, the class 1 to 5. So with the class 1 to 5, these are the limits, and we find the boundaries by subtracting 0.5 from the lower limit and adding 0.5 to the upper limit. So the lower boundary here is going to be 1 minus 0.5, which gives us 0.5. And the upper boundary is going to be 5 plus 0.5, which is 5.5. And this is the upper boundary. So these are what we use along with the frequencies to draw the histogram. And so I'm just going to put in the boundaries here, 0.5, and then fill in the upper boundaries, 5.5, 10.5, 15.5, 20.5. Sometimes the question that you're doing will actually ask you to put them in. Sometimes it will not ask you to put them in, but as the student doing the graph, you should know that you must draw the histogram with the boundaries and not the limits as appear on the table. So now that we have our boundaries, we start with the lower boundary and continue. We can now go ahead and draw our histogram. Now look at this, the specification that the question will give. It says use 2 centimeters to represent 5 kilometers on the horizontal and 1 centimeter to one student on the vertical. So we'll go here and we'll set up our graph. So because it starts at 1, we'll just start it here. So 0, 5, 10, 15, 20, 25, 30, 35, 40, and we'll just stop it at 45 here. All right, 45. And 1 centimeter to one student. So 1, 2, 3, 4, 5, 6, 7. It is important that you use the scale that CXC asks you to use, or whatever examination body that you're using. That when a scale is given, the examination body expects that you use that scale and not use any arbitrary scale, because often there's a mark for using the scale that is given. Here now we're going to be setting up our histogram. Start with 0.5. Now look at your scale here. 2 centimeters to 5 means that for each of these tiny boxes, each one represents a half. So we can easily draw our histogram by noting where the boundaries are. So 0.5 would be here, and 5.5 will be here, and the frequency for that is 1. So we're just going to you just take your ruler and you would draw that that box, that bar, pretty much like that. With the next one, the frequency is 2. So it's going to pretty much start here and go up to 2. Go over to 5.5. Sorry, 10.5. And that's what it will be. The next one will be 15.5 to 4. So we drop in that one, draw it across, 15.5, and then drop that one down to 15.5 to 4. Then 20.5 to 6. So here's our 6. We extend that one a little bit. 20.5 will be there to 6. And drop that one down to 20.5. 25.5 to 7. And we do the same thing. So you just move your ruler around and draw your histogram. And we have 3 more, 30.5 to 3. 1, 2, 3. Very good. That's it there. 30.5 to 3. 35.5 to 2. So there we go. And as we said, with this particular histogram, all the bars are equal because all the classes are equal. And the last one we have here is 40.5 to 1. And so we draw that one across, and there we go. We are finished drawing our histogram. Just one last thing to do, and that is to label our graph. So on this one, we have distance in kilometers. Always remember to label your graph. So we have distance. Label your axes rather. And on this axis, we have the number of students. So this is how you draw a histogram. You draw it using the boundaries and the frequency. And remember always to pay attention to your scale so that you draw it correctly. Until next time, thanks for watching and continue.